When I think of fate's worse than death, all I can think of was something you said. You said we were golden, bright like the sun. Now I am stranded, knowing I'm not the one. An ocean of anger flowing through me, bloodstained and broken from what I failed to see. And just like a snake charmer, you led me astray, living in distress, hoping help was on the way. In the midst of a storm, searching for shelter, I came upon one single feather, a half-hearted wish for something better, gracefully cursed, I thirst.
Tonight, the time before time began, the universe, black holes, God and the laws of science. Professor Stephen Hawking, Dr. Carl Sagan, and Arthur C. Clarke discuss the mysteries man faces as he starts to explore the stars. Dreadful disabilities prevent Stephen Hawking from speaking a word, but he's risen above them to become a brilliant mathematician and teacher. Using a computer-driven voice synthesizer, he's told the world how the universe began, and now he's seeking the ultimate theory of how it works. Arthur C. Clarke invented the communication satellite long before the technology existed to launch one. That vision of the future fathered the global village. His novels and stories, including 2001: A Space Odyssey, have inspired a generation of real-life astronauts. Carl Sagan sent man's first messages to the stars aboard NASA space probes. He's sure we're not alone in the cosmic wilderness. Dr. Sagan joined our discussion from Cornell University in New York State, so I checked whether he could hear us over one of Arthur's satellites.
Yes, communication satellite technology is working very well, thank you.
Arthur, can you hear all right?
I can hear fine.
And Professor Hawking, are you in touch with Carl Sagan?
Yes.
Professor Hawking, in fact, has just made publishing history by writing a book about hard theoretical science which has outsold even Michael Jackson in the bestseller lists. It's called A Brief History of Time, and we'll be talking about the concepts that are in it. Now, Stephen Hawking is engaged in a search for the ultimate answer, a grand, unified theory that would explain everything. Stephen Hawking, that is quite an agenda. How are you getting on with it? Let me just explain that what happens when Professor Hawking wishes to speak. He lost his voice a couple of years ago and now has to use a voice synthesizer, and he can control a squeeze box in his hand, and on the VDU screen on the arm of his chair he's got a vocabulary which scrolls through, and he can pick out the words that he wants, and these words are then assembled into a sentence, and when the sentence is ready then he can process it through the voice synthesizer. So whenever you're ready, Professor Hawking, we'd like to hear from you.
In the last 300 years, we have discovered the laws that govern the universe in all but the most extreme conditions. I think there is a reasonable chance that we may find a complete set of laws by the end of the century if we don't blow ourselves up first. If we do find a complete unified theory, it will be a great triumph, not just for scientists, but for ordinary people as well. In time, the unified theory would be simplified and taught in schools, at least in outline. Then, everyone would have some idea of how the universe works.
Well, that is a tremendous vision. Now, Carl Sagan, you wrote an introduction to the book, and one of the striking things that you said is that it's only children nowadays who ask the big questions because they don't know enough not to.
What I was trying to get across was the notion that the school systems, it seems to me, have a attitude of discouragement of asking fundamental questions. If a 5 or 6 year old asks why the moon is round or why grass is green, the usual adult answer, at least in my experience, is to discourage the child. Say, what shape did you expect the moon to be? Square? Or what color did you expect the grass to be? Blue? Instead of saying that those are interesting questions, let's try to find out the answer, or maybe nobody knows the answer, and when you grow up, you'll be able to discover the answer. It would be very healthy for the human species if there were less discouragement and more scientists.
Arthur Clarke.
One of the reasons why I write science fiction is because it does free the imagination and does inspire people to become scientists and astronauts. Many astronauts have made me feel a very old man by coming up and saying to me, you know, your books turned me on when I was a small boy.
Excellent. Now,
It would be very healthy for the human species if there were less discouragement and more scientists.
Arthur Clarke.
One of the reasons why I write science fiction is because it does free the imagination and does inspire people to become scientists and astronauts. Many astronauts have made me feel a very old man by coming up and saying to me, you know, your books turned me on when I was a small boy.
Professor Hawking, how did the universe start? With a Big Bang?
We observe that distant galaxies are moving away from us. This means that they must have been closer together in the past.
When Hubble made his great discovery, it was for galaxies like our own Milky Way galaxy, and they all followed the same rule, that the fainter they are, the larger their redshift. In other words, the faster they are moving away from us. This is known as the Hubble law, and directly led to the expanding universe theories. But in the 1960s, there was a new discovery, the quasi-stellar objects, often referred to as quasars. They appear as star-like points on the sky, frequently blue in color, and they have very, very large redshifts, implying that they are at huge distances from the Earth, at the very boundaries of the observable universe. Some astronomers soon found that a vast number of these strange new objects populated the regions around spiral galaxies, and were not only observable with radio telescopes, but were optical and X-ray sources as well. There were two properties of the quasars that were difficult for astronomers to understand using the expanding universe theory. The first was that if one plotted their apparent brightness against their redshifts, as one does for galaxies, one gets an unexpected scatter on the diagram, instead of the smooth curve made by the same plot done for galaxies. This seems to indicate that the quasars do not follow the Hubble law as do most other objects, and that there is no direct indication that they are actually at their proposed redshift distances. In fact, it is argued that if Hubble had first been given the plots for quasars, he and other astronomers would never have concluded that the universe was expanding. The second property was that quasars are very small, compact objects, sometimes only a light year across. So if quasars are really at their extreme redshift distances, They must then be the brightest and most energetic objects known to astronomers. So energetic, in fact, that untestable, almost metaphysical mechanisms must be applied to explain the phenomena. On the other hand, when placed at their observed distances, that is, in the neighborhood of nearby galaxies, their brightness and energies become normal, and no special mechanisms need to be evoked. This problem has led many astronomers to abandon the idea that all redshifts are due to their speed of recession away from the Earth. And if this is true, then there is no need for an expanding universe, and the Big Bang never happened. The Big Bang never happened. The questions arise. Is there a The questions arise.
Anything that happened before the Big Bang could not affect what happened after. So we can neglect events before the Big Bang and say that time began at the Big Bang. After the Big Bang, we believe that the universe expanded in a very rapid, inflationary manner. Again, this inflation in the universe quite puts modern economic inflation in the shade. An increase of billions of percent in a tiny fraction of a second. Of course, that was before the present government. During the inflationary period, the universe borrowed heavily from its gravitational energy to finance the creation of more matter. The result was a triumph for the economics of Keynes. A vigorous and expanding universe filled with material objects. The debt of gravitational energy will not have to be repaid until the end of the universe.
Well, I'd like to stay with this basic proposition for the time being, the Big Bang Theory. And to come to you, Carl Sagan, could you help me by putting into layman's terms what was involved with this Big Bang?
Well, here we are on a planet which is about 5,000 million years old. The sun around which it goes is not much older. It is part of a galaxy which is perhaps 10 or 12,000 million years old, which is one of perhaps hundreds of thousands of millions of other galaxies. And none of this, planets, suns, galaxies, was around at the time of the Big Bang. At the time of the Big Bang, there was energy, elementary particles, which slowly evolved into the kind of universe we know today. We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware. One of the great accomplishments of Dr. Hawking is to plug us better in to the knowledge of this long evolutionary sequence.
Well, what I have in my mind is a picture that Carl Sagan had been leading me towards of the whole universe in quite amazingly small packages, like putting the whole world into a matchbox, as it were, immensely dense and immensely tiny. And in fact, so tiny it's kind of disappearing into a little point. Is this the earliest imaginable point that our minds are taking us to so far, Carl Sagan?
Well, as Dr. Hawking said, the galaxies are expanding, running away from each other. The further away they are from each other, the faster they are running away. If you run the cosmic movie back into time, you come to a moment, perhaps 15,000 million years ago, in which all the matter in the universe was touching in, if you like, a point. And a key unanswered and perhaps unanswerable question is, where did all of that matter energy come from? What was before that? And if it was made from nothing, who made it? And who made the maker? And of course, an infinite regress behind that.
Is the universe still expanding fast? I mean, is there a lot more room in space, as I think of it, for the universe to carry on getting bigger?
As far as I know, nothing in the way, and the expansion continues. The question is whether there is sufficient matter in the universe, matter that we have not yet counted, that will slow the expansion down, stop it, and have the expanding universe followed by a collapsing universe, or whether there is not enough matter to stop the expansion, and so the expansion then continues forever. This is an observational question which is still unresolved, and the Hubble Space Telescope, which who knows might be launched next year if we're lucky, might answer this question.
Professor Hawking uses a very striking metaphor of the Earth borrowing its energy from itself. Now, in straight banking terms, that means you're going to be overdrawn, and in the end there's going to be a collapse, a big crunch. So does Big Bang get followed inevitably by Big Crunch?
No, not inevitably. It depends on how much matter there is in the universe, which is a still unsolved issue. I should say that the prevailing opinion is that the universe will continue expanding forever, but that, in my opinion, is by no means a very secure conclusion.
Well, let me bring in the poet amongst us here. Arthur Clarke, you know what T.S. Eliot said, "This is the way the world ends, not with a bang, but a whimper." When you think of the end of the world, if you think of the end of the world, does it end with a bang or a whimper?
Well, one would like to think that we will end with a bang. Of course, we'll never know. It's a rather a long way in the future. Some billions, tens of billions, possibly even much further in the future. And as Carl said, we may have the answers to these questions in a very few years if the Hubble Space Telescope gets successfully into orbit and can peer out to the boundaries of the universe.
If we are sort of living in a little suburb of the galaxy, can you foresee a time when we need to get out of the suburb and colonize somewhere else because of the gradual curve towards the end?
Well, I think the human race, if it survives the next few years, will go on to colonize first the solar system and then to send ships out to the stars and ultimately perhaps to other galaxies. But if the expansion of the universe is fast enough, we will never be able to keep up with it.
Now, one fascinating aspect that is raised is the question of time itself in the book. Now, we all think that we know what time is. It's a relentless march forward. But for the purposes of your argument, Stephen Hawking, you use a mathematical concept that you call imaginary time, which seems to be able to run backwards as well as forwards.
In our theories, there are two kinds of time. There is what is called real time. This is a kind of time that is measured by a clock. The time that we feel passing, the time in which we grow older. Then there is imaginary time. Of course, imaginary time is an idea that science fiction writers, like Arthur, have used in their stories. But imaginary time is also a well-defined mathematical concept. It can be thought of as a direction of time that is at right angles to ordinary, real time, in a certain sense. The universe has a beginning in real time, at a Big Bang. And it may well have an end if it collapses to a big crunch. But in imaginary time, it has no beginning or end. Rather, imaginary time is closed in on itself, like the surface of the Earth. The surface of the Earth doesn't have any beginning or end. I know, because I have been round the world, and I didn't fall off. Individual particles can travel through imaginary time and arrive back at an earlier real time. but I don't believe that people will ever be able to travel back in time, like in the film Back to the Future.
Do you see the actual role of science fiction? Is it purely escapism, or do you see it as having a very real purpose in broadening our patterns of thinking, opening our minds to the kind of vast concepts which we're discussing today?
Well, first of all, there's no objection to escapism in the right places. In fact, C.S. Lewis once remarked to me, the only people who object to escapism are jailers. And we all want to escape occasionally, but science fiction is often very far from escapism. In fact, you might say that science fiction is escape into reality. It's a fiction which does concern itself with real issues, the origin of man, our future. In fact, I cannot think of any form of literature which is more concerned with real issues, reality.
Well, what do you have to say to that, Professor Hawking?
I don't believe in stories of flying saucers and other unidentified flying objects. If time travel were possible, we should have already been visited by people from the future. I think if we were being visited by people from another time or another planet, it would be much more obvious and probably very unpleasant. I don't want to make contact with another civilization, except at a safe distance. It might be like the North American Indians making contact with the white men. I bet they wish they had never sold Manhattan.
I'll bet they did now. Carl, you are the world's leading expert in the search for extraterrestrial intelligence. Now, Professor Hawking doesn't want to make contact with them. Why do you want to make contact with them?
Well, first off, I would say we have little choice in the matter. That is, we have already announced, or rather I should say, Magnus, you fellows have already announced the fact that there is a low-level technical civilization in this part of the galaxy, because television programs get out at the speed of light, since any other civilization who detects those signals is unlikely to be at or before our state of technological advance, since we just invented radio technology, so to say, they are much more likely to be in our technological future. And the question as to whether their intentions are benign or otherwise is, of course, of interest, but we have nothing to say about the matter. So therefore, I think we might as well hope that it's benign if they're out there. From my point of view, the search for extraterrestrial life, and especially the search for extraterrestrial intelligence, is one of the key philosophical, scientific, and human questions that have been posed. But we are at the very beginning of searching. Surely it is important for us to know the answer.
One thing that interests me a great deal is the way in which the public perception of beings from outer space have changed over the years. They used to be the baddies, but now there's a sort of optimistic feeling that any extraterrestrial life is, if not benign, is at least not as hostile and aggressive as one used to fear. Is this the drift of your writing as well, Arthur? Your thinking?
Yes, I'm an optimist, and I believe that any malevolent super-civilization would rapidly self-destruct, as we may be in the process of doing ourselves. So if we do have contact, physical contact with aliens, I think it will be benign.
My frivolous mind is much taken.
Very intelligent beings reasonably near. Why have they not visited us?
Well, that's a very good question. Let's throw it right across to Arthur Clarke.
There are literally dozens of answers to this. They may have come in the remote past. They may be visiting us every 10,000 years. I mean, the universe is a huge place, and even if there are fleets of survey ships going all over the cosmos, we shouldn't expect visitors less than, I'd say, every 1,000 years or so. They may know all about us, and they may have put a quarantine around our planet for pretty good reasons. They may be totally uninterested in us. They may be so much higher that they You know, we're just beneath contempt, if you like. You can speculate endlessly. I think we should just wait and try and get more evidence.
Maybe their space probes are saying there's no intelligent life on Earth.
They may have received our television programs and decided that that is the case.
May I?
Why rather than the how. And I quote, "If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God." Do you think that God can intervene in the universe as he wants, or is God too bound by the laws of science?
The question of whether God is bound by the laws of science is a bit like the question, can God make a stone that is so heavy that he cannot lift it? I don't think it is very useful to speculate on what God might or might not be able to do. Rather, we should examine what he actually does with the universe we live in. All our observations suggest that it operates according to well-defined laws. These laws may have been ordained by God, but it seems that he does not intervene in the universe to break the laws, at least not once he had set the universe going. However, until recently, it was thought that the laws would necessarily break down at the beginning of the universe. That would have meant that God would have had complete freedom to choose how the universe began. In the last few years, however, we have realized that the laws of science may hold even at the beginning of time. In that case, God would have had no freedom. The way the universe began would be determined by the laws of science.
Well, thank you very much. And Carl Sagan, in your introduction to the book, you commented on this. You said this is also a book about God, or perhaps about the absence of God, because Hawking left nothing for a creator to do. Now, God, of course, means many things to many people. What sort of God, basically, are we talking about when we talk about reading the mind of God?
Well, I think that's an excellent question, and I'd be most interested to hear Stephen Hawking's answer. But just to try to illuminate the range of possibilities, consider two alternatives. One is the notion popular in the West of God as a sort of outsized, elderly white male with a long white beard sitting in a throne in the sky and tallying the fall of every sparrow. Contrast that with the idea of God in the mind of, let's say, Spinoza or Einstein, which was, at least very closely, the sum total of the laws of the universe. Now, it would be madness to deny that there are well-defined physical laws in the universe. And if that's what you mean by God, then there's no question that God exists, but it's a very remote God, what the French call roi fainéant, a do-nothing king. On the other hand, the former model, the one who intervenes daily, for that there seems to be, as Dr. Hawking said, no evidence. I think it is wise, my own personal feeling, to be a little humble on such matters. We must recognize that we are dealing with, by definition, the most difficult things to know, the furthest from human experience, and perhaps we will be able to penetrate a little way into these mysteries.
I think, Professor Hawking, you'd like to come in here.
I use God in the same sense that Einstein did. It is really the reason why the universe is as it is, and why the universe exists at all.
Can I ask Arthur Clarke what he meant when you're alleged to have said to the papal nuncio, "I don't believe in God, but I'm extremely interested in him"?
Well, I guess I haven't placed my bets yet. And, you know, Stephen's remarks and Carl's remarks reminded me that this was said 200 years ago, when Napoleon, I think, was talking to Laplace, who published his theory of the universe, and Napoleon said, God isn't in it. And Laplace replied, sir, I have no need for that hypothesis.
Do you think that the Church is, in fact, beginning to recognize that it may have to lose its priority, its eminence as the sole arbiter of these matters, and that science will be allowed to come in as an equal partner?
Well, the Church is certainly, when I say the Church, the Roman Catholic Church has become very much more liberal. I had the pleasure of giving a talk in the Vatican myself in the Pontifical Academy of Science quite recently, and met the Pope. And of course they're reinstating Galileo, and so things are moving.
In fact, are they moving backwards as well as forward, Carl Sagan? Because I understand that in the earliest days of civilization, then the priests were in fact what we call the scientists, the ones who could study astronomy and who could predict eclipses and things. Do you see the scientist coming back into an almost sacerdotal position like this, or am I overstating it?
Well, I hope you're overstating it. I think the essence of the scientific method is the willingness to admit you're wrong, the willingness to abandon ideas that don't work, and the essence of religion is not to change anything. That supposed truths are handed down by some revered figure, and then no one is supposed to make any progress beyond that, because all the truth is thought to be in hand.
I'm really talking about setting an agenda for the future.
My sense is that the scientific way of thinking, questioning, some delicate mix of creative encouragement of new ideas and the most rigorous and skeptical scrutiny of new and old ideas, I think that is the path to the future, not just for science, but for all human institutions. We have to be willing to challenge because we are in desperate need of change.
Can I put the same question to you, Arthur Clarkson? Politicians or priests are setting the agenda, or scientists?
I'm very fond of quoting Pandit Nehru on this, and he once said that politics and religion are obsolete. The time has come for science and spirituality.
I hear from the clicking that Professor Hawking would like to come in.
I don't think that physics tell us how to behave to our neighbors.
Sorry, but I don't want to be an emperor. That's not my business. I don't want to rule or conquer anyone. I should like to help everyone if possible. Jew, Gentile, black man, white. We all want to help one another. Human beings are like that. We want to live by each other's happiness, not by each other's misery. We don't want to hate and despise one another. In this world, there's room for everyone.